Hi guys, so today we will be solving this problem called find largest value in each tree row. In this problem, we've been given the root of the binary tree and we need to return an array of the largest value in each row of the tree. And yeah, that's the idea. Let's see with an example first. Uh, Let me draw this first. So first one is 1, 3, 5, 3, 2, and 9. So if you see at each level, uh, what is the largest value? So in the first level, 1 is the largest value because that's the only sole node available on that level. And then on the second level, it's 3, that's the largest value. And then on the third level, 9 is the largest value. So on each level, there is a largest value, and that we are getting it in the array. After that, once we know like at each level what is the largest value, we need to put it in an array and then we need to return that. So it's very simple. What we need to do is just traverse through. So we can use BFS. We can traverse through each level and actually store like a current. We can use a current max variable and store each value and compare it to each value with the current max. And if it's the maximum possible value at that level, we'll add it in the vector, which is vector or array, whatever. We'll add it there and keep on going and iterating through each level and storing it in the current max. And yeah, they definitely like that will give us the final answer. So let's quickly do a dry run of how we can actually do that, or the approach that I just told you. So we'll we'll store like we'll have, because it's a VFS, so we use Q. So Q. So Q will first of all will have the root of the node. So Q will have 1 in it, right? And yeah, when we are doing BFS traversal, we pop the first element. So first element is popped. And we have like current max. Let's say current max is right now negative infinity, right? So we pop that out. We see current if the nodes left and right exist. Yes, it exists. So we'll push that in the queue. So 3 and then 2 is pushed. So 1, with 1, what is the maximum value at that level? So minus infinity. So we'll compare with the current maximum. So current maximum minus infinity, and this is 1. So what is the maximum value? 1 is maximum value. So we know that at level 0, that is the maximum value, right? So that's done. Then we come to the next level. So next level, we have 3 and 2 in the queue. 3 and 2 in the queue. So we'll pop out one by one. So 2 is popped out first. So 2, 2 will have, does it have a left and right child? Yes, it has 9. So we'll push that in the queue, right? So 9 is pushed, right? And then uh, we we compare it with the current max. So current max is currently negative infinity because it's the second level and it's also initialized again. So it's negative infinity compared to 2. So 2 is the largest. So current max currently becomes 2, right? And then we pop out the second element from the queue, which is 3. We'll ask 3. We'll ask 3 if left and right exist. Yes, it does exist. So we'll push it in the queue. So 5 and 3 again. So 5 and 3 again. That's what's pushed in the queue. We'll compare this with the current max. So 2 is the current max and this is the 3. So 3 is larger than 2, right? So current max will be updated to 3, right? And then we go to the next level. So 3 is the current max on this level, right? Next level, we have 9, 5, 3. So similarly, we'll pop each element outside, compare it with the current max. So 9 is popped out first, and current max is currently like again, it becomes because it's the next level. So it's the next level, and at next level, we'll have minus infinity as current max. So 9 is when 9 is popped out, we'll compare both of these, and current max become 9, right? Because that's the largest. Then we pop out 5. Also, yeah, we check if left and right exist. 9 does not have any left and right. So yeah, and then we come to 5. 5 is compared with current max again. So 5 and 9, both of them, yeah, 9 is the largest, so we do not need to update the current max. Then we pop out 3. We check 3 left and right exists null point because it's null, so we do not need to add anything there. And moving forward, we'll have to compare this 3 with the 9 current max. So 9 is the largest, so that remains as it is. So that level is covered. The traversal of this level is done. So we come to the current max, basically storing it in the result array. And yeah, that's the traversal for the entire tree, and we return the final answer as this array, which is 139. Cool. I hope you guys understood the dry run. Let's get to the coding part in order to understand this better. Cool. Let's get to the coding part. So first of all, if root is none, right? That's the base condition. We'll return an empty, right? And then moving forward, now we have q, dq, and we'll store the root in it. So q will have initially a root inside it with every BFS traversal. It has that. We'll iterate through the queue. First of all, what we'll do is we'll need to know the size of the queue. So queue size. And then we also need to maintain a current max, which I told you, which will be currently be negative infinity. Right. And now we'll iterate through the level, each level. So for I in range size, we have to first of all pop out the element from the queue and also compare this value with the current max. So max of current max and node dot val, that will be compared. And yeah, moving forward, we have if node dot left exists, right? If node dot left exists, then we'll actually put q dot append this node dot left, right? If node dot right exists, then we'll have q dot append node dot right, right? And yeah, that's the idea. Uh, all of those will be appended in the queue. And moving forward, we'll have another, yeah, now we have the current max. So we'll have the another result array. Actually, we'll need to create a result array where we'll add all these current maximum of each level. So result dot append current max. Yeah, and that's the idea. And we'll return the result in the end. Cool. So let's run this to see if everything is working fine. Yeah, that works. Cool. I hope you guys understood the problem. Thank you so much. Bye.